renal artery, and then where are the segmental at?
There.
Good. And then where are the interlobular?
Here.
Good. Because technically this whole area is called a lobe.
Yeah.
This one is.
That makes sense.
And so it
Remember.
goes between
Okay, so
interlobular.
Okay.
The arcuate is where? Did you find that one? Good. Where it wraps around the top part of the pyramid. These are called renal pyramids.
Okay.
So their bases, the wide part is up here, and so arcuate wraps around the top.
Okay.
Renal artery, segmental, interlobular,
Arcuate.
Okay. And the ones that radiate out into the cortex are called the cortical radiate arteries. So they're pretty descriptive.
Okay. Okay.
And the afferent goes
And then into the glomerulus, which there's a close-up.
Is that what this is? Okay.
Okay. So here are the ones hugging the pyramids. Therefore, this is the cortex. This is the medulla.
Arcuate.
Arcuate. Good. Cortical radiate.
Okay.
Going into the glomerulus is the afferent artery. Always the widest one of the two.
Okay.
Widest of the two.
Into the very leaky ball of capillaries that are surrounded by these Bowman's capsules that catch anything small enough to get through the fenestrations here. And there are millions of these little glomeruli per kidney.
Okay.
Blood, then anything that doesn't go into the capsule gets put into the efferent arteriole, which is narrower, and that's why the blood pressure is a little bit higher than in other places of the body. Large highway in, narrow highway out. It pools here and increases the pressure. So that facilitates filtration in this area. Efferent arteriole, and then we're just going to go into a big network of capillaries that surround these tubules. Okay, and so anything that gets filtered goes into this Bowman's capsule and into a bunch of other tubular parts.
Like the
These tubular parts are surrounded by capillaries called peritubulars surrounding. So after the efferent arteriole, we go and wrap around the proximal convoluted tubule. There's a distal convoluted. These tubular elements here. And that's anything that doesn't get filtered at this glomerulus area, we can handle over here. So if we want to keep something, right, that got filtered like glucose and put it back into the capillaries, that's where it happens in those peritubular capillaries. Same thing if you want to have waste that didn't get filtered here, but circles back around into those peritubular capillaries, then the waste can be secreted back into the tubular element and then eventually put into the urine. And so it goes efferent arteriole, peritubular capillaries, and then it just marches back. There's a cortical radiate vein, arcuate vein, and it just goes back.
So there's the arcuate vein.
See right here, peritubular capillaries. So it's not showing so you can see the
This is
tube.
the arcuate vein.
Weird vein.
Okay, so you're just going backwards into the
There are no segmental veins though. So note when you get to the interlobular, it goes right to the renal vein. So technically, this whole span is, I don't know why they have that designation.
They don't have the bular on the flow chart here.
I'm sorry, which one?
Like like in the book, they're talking about like interlobular, and like these are just lobars.
Radiate.
Oh,
I think it's more descriptive to use.
Yeah. Okay.
I would use that.
Okay.
And I have a tendency to use that name. So that,
Okay.
I think it's more descriptive.
Yeah. I was like, okay.
And then the vasa recta.
They're both the peritubular capillaries and the vasa recta are both capillaries that come after the efferent arteriole. But the vasa recta spans this area of the tubules called the loop of Henle.
Yes.
Whereas the peritubular capillaries surround the loops up here.
So it says and or. So what determines where it flows?
It depends what nephron you're working with here. The nephrons with the longer loops are probably going to have a tendency to shift blood to the vasa recta area after the efferent arteriole.
So if you point to a green section, that would be, or just this.
If you after the Bowman's capsule here, this little area is called the proximal tubule or proximal convoluted tubule, the first one, and then it goes into the loop of Henle. And then it goes into a second convoluted part called the distal. So it's always proximal first, then distal. Proximal is always going to be attached to the capsule. So this is proximal. Here. And then the last spot, and it's considered urine here, this is the collecting duct. Those are all the collections of tubes that form in the medulla. So urine's actually formed in all of these units, these nephron units, in the cortex. It's collected in collecting ducts and then goes through the various funnels.
Papillary ducts.
Is it the same as
someplace.
The papilla end of the medulla is this pointed end. Each of them are connected to a minor calyx. So the collecting ducts, all of these things dump into a minor calyx. And then where two minors meet, there's a major. And then this last wide area before the ureter is the renal pelvis. So urine formed up here, drips down collecting ducts into the minor calyx, then a major renal pelvis, and then out the ureter.
Does this have anything to do with the lymphatic system?
It does not.
It does not? Okay.
No, this is the tubular part where anything, so about 20% of the blood that gets in here, the fluid in that, is pushed into the Bowman's capsule. The other 80% goes out the efferent arterial and into those peritubular capillaries or vas recta. So sometimes we get filtration here, lots of filtration, because these are very leaky capillaries. And so some of our glucose and stuff gets filtered here, and some of it does not get filtered. But either way, we need glucose. So if it gets in here, it has to be sucked up later on by those peritubular capillaries. So you shouldn't have sugar in your urine unless you have uncontrolled diabetes. Yeah. So some things get reabsorbed back in. Okay, so if they don't get filtered and we need them, they stay in those peritubular capillaries and go back into circulation. But if they do get filtered and we need it, these tubule cells have little transporters that sucks them back up into the blood. And at the same time, if we don't need the substance, it comes out of the peritubular capillaries and back into the nephron, if it didn't get filtered here originally. So all of these millions of little glomeruli, balls of capillaries that are in this cortex, those are the urine makers. And so at these various places, you get reabsorption, secretion, or both. We'll talk about that element in the lecture. Most of the places you get both. Collecting duct mainly, you're done with reabsorption and secretion. That's where water is controlled. That's where ADH acts. Keeping your water on that collecting duct area. So if you're dehydrated, little water pores are put into that, and that sucks it back up into the blood vessels. If you're hydrated, then the urine will go out in high quantity. So hormonal control is more at this end, and the reabsorption and secretion mostly happens at the first little tubule, that proximal one. The first, little bit.
Got that?
Thank you. Yeah.
So